Hello, 7th grade. We're on lesson 4 of our chapter on magnetism and electromagnetism. This lesson we're going to look at electricity, magnetism, and motion. So, first, let's read from the textbook. Remember, I'll read it to you. So just a second here. Okay, so we're going to learn about a miniature motor. So, in 1960, scientist and California Institute of Technology, or Caltech, Professor Richard Feynman publicly offered a prize of $1,000 for the first person to build an electric motor no larger than 0.3969 cubic millimeters. Really, really small. A Caltech graduate named William McClellan accepted the challenge. He used a toothpick, microscope slides, fine hairs from a paintbrush, and wires only 1/80th of a millimeter wide to build the world's smallest motor. McClellan showed his tiny motor to Feynman and collected the $1,000 prize. Scientists today have found many uses for tiny motors in products such as high-definition televisions, cars, and inkjet printers. Okay, I know you can't really see it, but here is his little itty bitty motor. You can see how small it is compared to a pencil. Okay, so now let's answer the question. What might be some other uses of tiny motors? I thought of a motorbike. That would probably have a pretty small motor. I mean, I know that it has to power the bike, but it would probably have a pretty small one. And then I thought of an HD computer, because the story talked about high definition television, so why not a high definition computer? So, our key questions for today. 1, how is electrical energy transformed into mechanical energy? 2, how does a galvanometer work? And 3, what does an electric motor do? Just going to move my little bubble up to the top there. So first, what is energy? Energy is the ability to move an object over a distance. Electrical energy is the energy associated with electric currents. Mechanical energy is the energy an object has due to its movement or position. So maybe like a bike. Think about a bike for that one. And your electrical energy is going to be what type of energy you have to turn on like the lights in the house. So energy can be transformed from one form into another. So our first answer to our first key question is, when a wire with a current is placed in a magnetic field, electrical energy is transformed into mechanical energy. So it's transformed from electrical to mechanical energy. So what's a galvanometer? Well, it's a device that measures small currents. And then there's straight wire in a magnetic field versus a loop of wire in a magnetic field. So it says the basis of a galvanometer is the rotation of a wire loop in a magnetic field. So when you think about like your regular energy and currents, straight wire, but a galvanometer uses the rotation of that loop of wire. Okay. So then what's the answer to the next key question? An electric current turns the pointer of the galvanometer. So that's how it's going to measure it, because the current turns the pointer. That's how it can tell how much is in those little currents. So an electromagnet is suspended between opposite poles of 2 permanent magnets in a galvanometer. So what does that look like? Well, here's your pointer, and then here you have the wire between the 2 ends of magnets. Okay. So the coil is attached to a pointer. I'll move this and move it right back. When a current is in the coil, it produces a magnetic field. So when there's no current in the coil, it does not produce a magnetic field. Then it says this field interacts with the permanent magnetic fields, causing the coil and pointer to rotate. Okay, so what do you use a galvanometer for? Well, you can use it to measure an unknown current, such as the current a person's skin conducts. Did you know that your skin conducts a current? So people who are stressed tend to sweat more, and water conducts electricity. So the moist or sweaty skin conducts more electric current. So if you want to measure the current your skin conducts, wait till you're really, really sweaty and then measure it with the galvanometer. Otherwise, electricians use them a lot of times in their everyday jobs. And then some cars actually even use a galvanometer as a fuel gauge. Thought that was really interesting. Okay, so let's look at an electric motor now. Move my bubble again. So, an electric motor is a device that uses an electric current to turn an axle. An electric motor transforms electrical energy into mechanical energy. So again, looking back at how energy can be transformed into different forms. So a simple electric motor has 4 parts. 1, permanent magnets. 2, the commutator. 3, the brushes. And 4, the armature. So let's look at a picture here. So in this picture, we can see the permanent magnets, which are producing a magnetic field, which causes the armature to turn. Here we have the armature, okay, both the purple and the green. The armature is a loop of wire that current flows through. So then we have the brushes, which are on the ends of the armature. It says the brushes conduct current to the rest of the commutator. They do not move. And then the commutator, which is there on the end of the armature, consists of 2 semicircular pieces of metal, which you can see. It conducts current from the brushes to the armature. Okay? So let's move my bubble again. Let's go through the vocabulary from this lesson. So we had energy, the ability to move an object over a distance. Electrical energy, the energy associated with electric currents. Mechanical energy, the energy an object has due to its movement or position. A galvanometer, which is a device that measures small currents. And then an electric motor, a device that uses an electric current to turn an axle. So that's the end of lesson 4. Your assignment is also stated on Edmodo, but you're going to be answering some questions from this lesson on Edmodo. They aren't due till Tuesday, but make sure you do get them done. If you have any questions, as always, let me know. But otherwise, have a great rest of your Thursday.